Hello, this is Kevin, and welcome back to our calculus session. Today we'll be talking about integration by parts, which can be a bit tricky with some of the complex integrals you'll do using this technique. As we discussed before, there are only three things you'll learn in calculus: how to approximate teeny tiny things, and that's limits; how to subtract teeny tiny things, and that's derivatives; and the reverse of that, how to add teeny tiny things, which is integrals. And for every one of the rules you're learning with integration, every one of them is the reverse of one of the rules for derivatives. When you learn the power rule for integrals, it's just the reverse of the power rule for differentiation. Learning U substitution is the reverse of the chain rule for differentiation. And the same thing goes for integration by parts. It's just the reverse of the product rule. So if I have a function, f of x equals u times v, and I'm going to go ahead and share my screen here. Give me a moment. Go. I can take the derivative of this, and I get that uv prime equals uv prime plus v u prime. Well, if I wanted to go backwards on this, I could take the integral of uv prime dx and say that's equal to the integral of uv prime dx plus integral of vu prime dx. What does that give me? Well, when I've taken the integral of the left side, I just get uv because that thing is in parentheses. And that's equal to the sum of these two integrals. And I can then move things around a bit, and I'll get that the integral of uv prime is equal to uv minus the integral of vu prime. Well, what have we done here? Why is this useful? Well, it's useful because sometimes we might have an integral of two things, and one of them has a derivative that's much simpler, and the other one has an integral that we can take easily. So in looking at the two pieces of this, you want to select u and v so that the derivative of u is much simpler and the integral of v is easy. Let's walk through an example of this. Let's say we wanted to take the integral of x natural log of x using integration by parts. So which one are we going to set to u and which one will we set to v? Well, natural log has a very simple derivative, 1 over x. So whenever you see natural log, you're going to want to make that u in these integration by parts problems. So we're going to set u equal to natural log of x. And I'll call this, sometimes it's nice to make a little table. Here's f of x, and then my next one's going to be f prime of x. And we're going to make v equal to the other piece, x. What is the derivative of u? Well, that's just 1 over x. And the integral of x is 1/2 x squared. And now we can just fill in the blanks. We can just plug into this equation and get the answer. The answer is going to be 1/2 x squared ln x minus integral of 1/2 x squared times 1 over x. You can then take that integral, and this one's easy. It's just a power rule integral. We'll do that in a minute. But the whole point is that one of the functions is simpler when you take the derivative. The other one we can easily take the integral of. As another example, if e to the x is in here, you usually want to make that f prime of x because it's easy to take the integral of e to the x power. Let's finish this up, and you'll see that what I get, 1/2 x squared ln x minus the integral of 1/2 x dx gives us 1/2 x squared, whoops, ln x minus 1/4 x squared, and don't forget the plus a constant. One of the things I always do when I finish one of these problems is I'll go backwards and double check it, make sure I got the right answer. When I take the derivative of this, I'm going to use the product rule. 1/2 x squared times 1 over x plus 1/2 of 2x ln x minus 1/4 of 2x. I then get 1/2 x plus x ln x minus 1/2 x. Hey, it worked. And by the way, this is also a useful technique if you're doing integration by parts and you're not sure the best way to do it, you can always guess and check. What happens if I take the derivative of x ln x? You can try it that way as well. Let's try another example together using the function x times e to the x. And which ones would you choose for u and v in this function?